everyone, welcome to the session. So in this particular video, we will talk about another problem for the substitution method. I hope that before coming to this video, you have already watched my previous video where I have talked about the problem number 1, where we have seen that how mainly that substitution method will work. It's just that for the recursive term that we have, we need to substitute the values. That's what we have understood. And then we have to see that how many number of times we need to do the substitution. That is, what is the value of k? And I have showed you in that session that how we can basically find out the value of k. After this, we have already discussed that how we can make some sort of series, mathematical series, which we already aware about all those series in our lower classes, right? And after that, we can take or pick up the higher exponential term and we'll get the answer, right? This is what we have understood in our last session. Let's talk about another problem, which is again a very interesting problem, you will see. Okay, so let's get started with this session. So here what we can do, just give me 1 second. Here, it is saying that the recursive term t of n, so the recurrence relation is t of n, which is equals to, again when it's a small problem, when the value of n is equals to 1, the answer is nothing but is constant, which is 1. But when the value of n is getting increment to greater than 1, the answer it says is t of n minus 1 plus 1 divided by n. So this is the problem statement that is given to us. So this is something which is a recurrence relation which is provided to us. Again, as I told you that how we are generating this recurrence relation, as of now, don't care about that, because that thing in complete our course, you will get an understanding once we get into the concept of any algorithm and data structure. But it's just that at that point of time when you will be able to generate a recurrence relation, you won't face any difficulty to get the time complexity part. That's why I am discussing this as a prior thing, okay? So let's get started. Again here, if you will see, this is something, as I told you, that recurrence relation will happen only in the recursive codes, right? When there is a recursion. Now this is something which we can say is a base case condition. Base case condition. Every recursive code, whenever you will write any recursive code, you always have some base case condition. Means that is the condition where your code will get terminated, right? So now let's get started with the thing. So here we are having t of n, which is equals to t of n minus 1 plus 1 divided by n, right? Now what we can do is that we will try to substitute the value of t of n minus 1. So can anyone tell me what should be the value of t of n minus 1? It should be nothing but t of n minus 1 plus 1 divided by n minus 1. Here, if you will see, I am just trying to understand the above pattern which is given in my question. This is the question which is given to me when the value of n is greater than 1. I am just trying to see the above pattern, and instead of writing this n, I am writing n minus 1 everywhere. Instead of writing n, we are just writing the value of n minus 1. I hope it's quite clear to everyone, right? So here we will be able to get the value as t of n minus 2 plus 1 divided by n minus 1. Now here, if you will try to observe this, we can write this value of t of n minus 1 as this. So the second equation after doing the substitution will get t of n minus 2 plus 1 divided by n minus 1 plus 1 divided by n, right? This is the thing that we are getting here. Now again what we can do is that we can again try to substitute the value. So this is the second equation that we are getting for a second time, right? Third thing, when we do the same thing third time, obviously now if I will try to substitute the value of n minus 2 here, so I will for sure will get t of n minus 3 plus 1 divided by n minus 2 plus remaining two things will be as it is, plus 1 divided by n minus 1 plus 1 by n. Here if you will try to see, this is the third equation that we are getting for doing this thing third time. Now, the question is that how many number of times I will repeat the same task. It's not like first, second, third, fourth, 10th. I don't want to waste my time to do the same thing again and again. The question is, how many times do I suppose to do the same task? So suppose we are doing the same task until k times. So here, if you will see, I know the value of t of 1. The value of t of 1 is something which is equals to 1 here. So here, we can say that I will do the same task until n minus k times. So when the value of k is, we are doing the same task k number of times. It's like when we are doing 2 times n minus 2, 3 times n minus 3. When we are doing k times, so it will be n minus k, whose value I want to be equals to 1, because that is the terminating condition, that is the base case condition that we have. So here the value of k will become n minus 1. The value of k will become n minus 1. It means that we need to do the same task until n minus 1 number of times, right? So if we are doing the same task until k times or until n minus 1 number of times, at that point of time, the value of t of n will become t of n minus k, right? Plus 1 divided by, here if you will see, always and always we are getting the number in the denominator as n minus k plus 1. Because here if you will observe, this is nothing but n minus 3 plus 1. Similarly, in above case, it will be n minus 2 plus 1. So here the value should be, n minus k plus 1. Plus again 1 divided by n minus k plus 2. Until so on, the same thing will get repeated until we are getting 1 divided by n minus 1 plus 1 divided by n. Here, now what we can do is that we can just try to replace this value of k with n minus 1. So we are getting the value as t of n minus 1, right? Plus 1 divided by n minus 1 plus 1 plus 1 divided by n minus 1 plus 2 until the value of 1 divided by n minus 1 plus 1 divided by n. Here if you will try to see, the value is n minus n plus 1, which is equals to t of 1, right? Plus this value will become n minus n plus 1 plus 1. So n and n will cancel out with each other. We will get the value as 1 divided by 2. Then we will get 1 divided by 3. You can just try to solve this. You will get 1 divided by 4 until so on, until the value of 1 divided by n minus 1 plus 1 divided by n. Here we know that when the value of n is equals to 1, the value will become 1, right? Because we know that the value of t of 1 is equals to 1 here. We already aware about this concept. So what we can do here is that we can try to just replace this value of t of 1 with 1 here. Plus we are getting the same thing. We can write it as it is, 1 by 2, 1 by 3, 1 by 4 until so on, until the value of 1 divided by n minus 1 plus 1 divided by n. So here if you will see, this is a kind of series. Is anyone aware about what this series is all about? Just think over it, just pause the video, take your time and do let me know what is your answer. This is a very famous series which is nothing but is a logarithmic series. That's why the overall time complexity that you are getting for this recurrence relation will be order of log of n. These are the kind of things which are very important because everyone I have seen is easily able to generate the recurrence relation. But what sort of approach do we use basically to solve that recurrence relation to reach to a final big O time complexity which we are reaching here? So this is nothing but big O time complexity, which will talk about a worst case scenario. That's where our target should be, right? So this is how basically we can do the thing with the help of a substitution method. I hope you guys find it very much easy and interesting, right? But apart from that, we do have two more methods which I have already illustrated in our previous video as well. And we will discuss those methods also in very much detail. Don't worry about that. But yes, I hope that this question which we have discussed in this session is pretty much clear to everyone. I'll try to solve few more problems on this method, and then we will try to go towards the recursive tree approach, okay, with the help of which we can solve different kinds of recurrence relation where we are having a multiple recursive terms. By saying that, here you will observe that we are having only single recursive term. Whenever we are saying T, whenever this term is repeating, just try to understand this is something which you can say is a recursive term here. So when you are having multiple recursive terms, then that recursive tree approach will be very much beneficial for us. But anyhow, we will discuss that in very much depth in the upcoming video. I hope that you all are excited with me to learn more about these methods. So stay tuned. Happy learning to all. Bye bye everyone. See you soon in the next upcoming session.